Now let's look at the common mistakes. These are the bugs that bite when you build a dynamic array in C, and how to avoid each one. This table has 3 columns: the mistake, the symptom you will see, and the fix. Let's go through each bug. First bug. You write data equals realloc of data straight onto the field. If realloc fails, you lose the block. That is a leak and your handle is now null. The fix is to assign to a temp, check for null, then repoint. Second bug. You forget to free data at the end of its life. That is a memory leak. The heap block outlives its handle. The fix is 1 vec free per vector. It frees the block and sets data to null. Third bug, you confuse size with capacity. If you loop up to the capacity, you read uninitialized spare slots. The fix is simple. Your loops stop at size, never at capacity. Fourth bug, you cache a pointer into the buffer, then you append. The block may move, so that pointer is now a useafter free or an old and wrong read. The fix is to reindex through data after any append. Fifth bug, you write to data at index size while size equals capacity. There is no room, so this is a heap overflow. The fix is to grow first, using the size equals capacity check. This is the one place where a little defensive code is the whole lesson. Realloc can return null. Here is the buggy version, with one pointer that we overwrite. Look at this line. We assign the result of realloc straight back onto data, our only pointer to the block. That is the trap. Now the failure case. When realloc fails, it returns null, but it does not free the old block. We just overwrote the only address of that block with null. The old block is still there, but we can never reach it or free it. That is a leak, and our data is gone. The fix is on the next slide. Here is the fix. We use a temporary pointer first, and repoint only on success. First, we store the result of realloc in a new pointer called temp. We do not touch data yet. Then we check temp. If temp is null, the grow failed, but the old block is still kept and still reachable through data. We return early and the vector is still usable. Only when temp is good do we repoint data to temp. This is the safe pattern. Temp equals realloc. If temp is null, handle it. Otherwise, set data to temp. This is a recurring rule. Production code checks every malloc and every realloc. Our other slides skip the check to stay short, but for realloc, the safe repoint is not decoration. It is the correct mechanism.